Hello everyone, welcome to the mechanics class. In the last session, what we have studied is we understood the concept of fixed axis rotation. Okay, we understood what is angular displacement and what is linear displacement, then what is the angular velocity, what is angular acceleration. Okay, and we also understood the two components of acceleration, that is tangential and normal acceleration, right? And what is tangential acceleration? Tangential acceleration is coming from the magnitude, changing the magnitude of the velocity, and angular acceleration is generated because of the change in the direction of the velocity. Okay, and we have proved the total acceleration is equal to under root of sum of squares of tangential and normal acceleration, right? We did this derivation and then we solved a couple of problems on it. Okay, and before studying this, what I have I have given some problems to you on let's say the variable acceleration, constant acceleration problems, then acceleration due to gravity problem, right? So variety of problems we have studied in the previous class. Okay, in today's session we will continue this fixed axis rotation. We'll solve some more problems. Okay, and then I'll start the kinetics part. Okay, but before jumping into the new questions, one question I have given you in the previous session. I hope some of you have solved it, but some of you have not. I will help you with the solution. Okay. So what was the question? The question was like the end of a rod. Okay, rod, which is, let's say, the end is A, has rightward component of velocity 2 meters per second. So let me draw the figure. Okay, so this is the rod we have, and this is the end A of the rod. This is the end A of the rod. Okay, and this is the x-axis, this is y-axis. And now let's what they have given is the rightward component of velocity is 2 meters per second. So this is 2 meters per second. What is the value? This is vx. And the upper component of the acceleration is 4 meter per second square. So they have also given the value of ay. Okay, this is given. The angular acceleration of the rod at the position. And what they're asking is angular acceleration. What is the position of the rod? This is, they have given as 3, 4, and length of the rod is 10 meters. Okay, so this is the given data. So this is 10. What should be the total height? This total height should be 6, and this should be 8, right? Then only sum of, let's say, squares of sides equal to the diagonal, square of the diagonal. Okay, 8 square plus 6 square is 10 square. Pythagoras theorem. So what we have to calculate from this is the angular acceleration. So let's try to solve this question in detail. So as it is fixed axis rotation, perpendicular, let's say, let me try to draw the velocity direction. So velocity will be in something in this direction. Okay, so this is the direction of velocity. Okay, This is theta. For this line, this is the perpendicular, and for then okay, for horizontal line, this is the perpendicular, and for this line, this is perpendicular. So this also has to be theta, and this also has to be theta. So what I can say is Vx is what? Vx is you can say either you can say it as uh, V cos of V sine of theta, you can say, or V cos of 90 minus theta. Because if this is theta, this is 90 minus theta, right? So V cos of 90 minus theta, you can say, right? I hope you understood. This is 90 minus theta. Now, so we got Vx, and yeah, they have also given an upward component of the acceleration they have given, right? So the value of the 80 will be somewhere in this direction, right? 80. And yeah, and the an will be somewhere here, normal acceleration. And let me use a red pen here or some green pen, an. Okay, and this is again theta, so the horizontal component of it will be an cos of theta, anx is equal to an cos of theta, right? Yeah, and the vertical component of an is any, and that is an sine of theta. Okay, so now more or less figure is clear. We have figure is complete, we can say. All the things we have almost written. So what is an normal acceleration? Okay, before jumping to the an, let's calculate this. What is the value of Vx? Vx is 2, which is given to us. So 2 is equal to V. You can write it as V sine theta also, because cos 90 minus theta is sine theta, right? And what is sine theta? Sine theta is perpendicular divided by hypotenuse. So that is 6 divided by 10, or you can write it as 3 by 5. V into 3 by 5. So this implies V is equal to 10 by 3. So it is 3.33 meters per second. Okay. So this is the use of Vx in order to calculate the velocity. If velocity is known, angular acceleration, the normal acceleration we can calculate, that is V square by R. So it is 3.333 whole square divided by R. R is 10 in this case. That is 1.11 meters per second. Okay. So this is our En. And Eny is what? En will have two components, Anx and Any. Okay. And Any will be An sine of theta, which we have already written here in the figure. And that will be again 1.11 into 3 by 5. That is 3.33 divided by 5, which is 0.66 meter per second square. Okay. So that's how we calculate Ny. Similarly, the AT will have two components. AT, let me use some maybe purple pen here. ATY and ATX. Okay. Okay, two components of ATY and ATX. What is the component of ATY? Vertical component of AT is ATY, and that is equal to AT cos of theta, right? And cos theta we already know, that is base divided by hypotenuse, so 8 by 10 or 4 by 5. So 80 multiplied by 4 by 5. Okay, or you can say 0.8 times 80. So 80y is 0.8 times 80. So there are total two accelerations which are along the vertical, let's say along the y-axis, that is 80y and any. 80y is upward, any is downward. So ay, that is upward component of the acceleration, is 80y minus any. Do you agree? And what is ay? That is, they have given us 4 meter per second square, and this has to be equal to 80y is 0.8 times 80 minus any is 0.66 meters per second square. So from this you will get the value of 80. What will be it? This implies 80 will be equal to 4.66 divided by 0.8. Okay, and that is 5.83 meter per second square. Okay, 5.83 meter per second square. So we got the 80, but we know 80 is what? 80 is r times alpha. R times alpha, and which is, what is the value of r? R is 10 times alpha. So this implies alpha is equal to 5.83 divided by 10. That will be 0.58. Okay, yes. Okay, is it clear to you all? Anyone have any doubt in this question? Now I hope uh, all of you understood this problem, how to solve it. Let me know if you have any questions. Okay, Srujana, I will repeat once again, no problem. Okay, listen carefully. So what they have given is two things. One is Vx, that is horizontal component of the acceleration is 2 meter per, horizontal component of the velocity is given, that is 2 meters per second, and a vertical component of the acceleration is 4 meter per second square. Okay, so these are the two things which are given to us, and they have also given the length of the rod, the slope at which rod is uh, kept, okay, with respect to the horizontal. So now, how to calculate this v from vx? Vx velocity we know is going downward. Why? If rightward component is here, then velocity direction has to be in this direction, right? It cannot be in this direction. If velocity is in this direction, let's say along 80 in this case, then the horizontal component will be in the left hand side direction, right? In this, but that is not the case. They have given rightward component. They have mentioned clearly rightward component. So the velocity direction has to be downward. Okay. So this is the first point. So the v will have two components. One is vx and vy. Vx will be 2 meters per second. And what is vx? Vx is equal to v cos of 90 minus theta, or you can call it as a v sine theta, because this is theta. So the horizontal component of the v will be v sine of theta, and sine theta is 3 by 5, and that's how we calculate the value of v here. Okay, so 2, which is horizontal component of the velocity, is already given, and we made use of it to calculate the velocity. If we know the velocity, we can calculate the normal acceleration. What is normal acceleration? V square by r. So 3.33 square by 10 will give you the value of normal acceleration. Why we are calculating normal acceleration? Because they have given us the upward component of the acceleration. So there are two upward component of the accelerations. Okay, one is ATY and ANY. So, and both are in opposite direction. So their subtraction is equal to the acceleration component in the y direction, right? Which is given to us. So we know AN is always directing towards center. So this is the correct value of or correct direction for the AN, and ANY will be acting downward. So ANY will be is equal to AN sine of theta. AN we just calculated, that is 1.11 into sine of theta is again 3 by 5. You will get 0.66. So you got the value of ANY. Now it's time to calculate ATY. Okay. So now ATY is what? AT cos of theta. AT cos theta. Cos theta is 4 by 5. So that is 0.8 times AT. So AY is given to us, that is 4 meter per second square. And that has to be equal to subtraction of ATY and ANY, right? Because the total component of the acceleration in vertically upward direction they have mentioned as 4 meter per second square. Okay, the component of the acceleration, the upward component of the acceleration is 4 meter per second square. What is that? It is a, let's say, summation of vertical acceleration or summation of acceleration along the y-axis. So one acceleration is going upward, one is going downward. So that is why AY is equal to ATY minus ANY. Okay, and AY is 4, ATY we just calculated 0.880, and ANY we just calculated, that is 0.66. This 0.66 goes here, that is 4.66 divided by 0.8 gives you 5.83 value of the AT, that is tangential acceleration. And what is tangential acceleration? R times alpha. And what is alpha? Angular acceleration. That is what required here as a solution. So AT is equal to 5.83, which is R times alpha. So alpha will be equal to 5.83 divided by R. The value of R is 10. So 5.83 divided by 10 is 0.583. Okay. So that's how we have calculated it. Is it clear, Sujana? Any doubt? Yeah. Okay, good. So this is one question. Maybe I'll give one question to you, one more for homework. You can try this. And if you still, let's say, unable to solve it, then maybe in the next session I can help you. The velocity of a particle is defined by Vx is equal to 100 minus t raised to power 3 by 2. Vy is equal to 100 plus 10t minus 2t square. Okay, where V is in meters per second and t is in second. Okay, the radius of curvature at top of its path is okay. I'll repeat the question. The velocity of a particle is defined by Vx. Vx is 100 minus t raised to the power 3 by 2. Vy is 100 plus 10t minus 2t square, where V is in meters per second and t is in second. Okay, the radius of curvature at top of its path is okay. Uh, so basically, they are asking for radius of curvature, maximum radius of curvature. Okay, suppose this is the curve, for example, then this is the what they are asking. Okay. Uh, Vx and Vy is given to you. Maybe think on it this question and try to solve it. Final answer here is 155 0.86 meter. Okay, you should get it. And if you still find any difficulty, maybe I can send you the solution, or you can discuss it in the next class. Okay. Let me give you another question, which we'll solve now on the same fixed axis rotation. A particle is thrown the questions which I am giving to you for homework are like little tricky. Okay, you have to spend some time on it. That is the main intention behind it. Okay, uh, if you spend some time, try to solve it on your own, then like you understood the topic completely, right? So that is the overall intention. In case you are not able to solve, I can help you. Okay, but you should try on your own first. A particle is thrown up in the air with a velocity of let's say 100 meters per second, making an angle of 60 degree with horizontal. Determine the radius of curvature. Determine the radius of curvature at the at let's say time t is equal to 1 second. Time t is equal to 1 second. Okay, very simple question. A particle is thrown up in the air with a velocity of 100 meters per second, making an angle 60 degree with the horizontal. And initial velocity is 100 meters per second. Okay, determine the radius of curvature at time t is equal to 1 second. Okay, solve it. Determine the radius of curvature at time t is equal to 1 second. See, as of now, the particle is making 60 degree with the horizontal, and it is at 100 meters per second. But we are working against a gravity, so maybe after 1 second, the velocity will be a little less, and the angle will be a little different, right? So that is what we should be first focusing on, and at that situation, then we can calculate the radius of curvature, right? So let's try to understand it. So let's say after 1 second, maybe particle is somewhere here, right? And let's say this is the direction of velocity, and Vx It's Vy, and here the angle will be something different, maybe alpha. Okay. Here the tangential component of the acceleration may still like this. Normal acceleration is perpendicular. It's somewhere like this. Okay. And so this is just to explain how the figure will look like after 1 second. So V naught Y, you know, that is 100 cos of 60, and V 100 sine of 60, and V naught X is 100 cos of 6. And so how will you calculate the V1X? V1X will be same. That is 100 cos of 60, and that is 50 meters per second. What about the V1Y? V1Y is equal to U minus 80, V minus GT, so it's a V naught Y minus G times T. So it's 100 sine 60 minus 9.81 into 1. Okay, so it is 76.79 meters per second. Okay, so this is V1Y. We got the value of V1X, we got the value of V1Y, and now we can calculate under root of V1X plus V1Y, 50 square plus 76.79 whole square, that is 91.6 meter per second. Okay, so we got the value of V. What will be the value of tan of alpha that time? And that will be Vy by Vx, right? Uh, that is, so this implies theta is equal to tan inverse of 76.79 divided by 50. It is 56.9. Okay. Uh, no, Abhishek. Something wrong with your answer. Please check once again. Okay. So what is the value of An here? Normal component of the acceleration we know is V square by R, or you can say R omega square also, whichever you want. So from this, R can be written as V square by An. Okay, V square by An. So you know the value of V. You should know the value of An in order to get the radius of curvature. How to find An? That is the main question. Okay. So uh, here the An will have two components. Okay. Uh, maybe what I can say. Uh, Total, let's say. Uh, let's say, for example, in this case, mm, what is cos of alpha? Let me show you what again alpha will look like here. For this is the perpendicular. I think this also has to be alpha. Okay. So, sorry, alpha, because for An that is the perpendicular. Yeah. So, uh, okay. What we know is what is the component of the acceleration? What is the downward component of the acceleration? And that is nothing but the uh, acceleration due to gravity, that is 9.81. Do you agree? Because That's we are working against the gravity. So the acceleration, the component of the acceleration um, here in this case is we can say the downward component of the acceleration in this case will be um, 9.81. That is acceleration due to gravity. That is g, you can say. Okay, so I can say that um, cos of alpha, you can write it as maybe let me yeah, you can write it as a divided by an. Okay, and the value of a here is 9.8, or g divided by n, rather g is 9.81 divided by cos of 56.9. Okay, and the value which you'll get here is maybe sorry, no, keep it as it is, and from this you calculate rather en is equal to g divided by cos of alpha. Let me go to the next page, and 9.81 divided by cos of 56.9, I think you will get 5.36 something. And now en is v square by r, and this implies r is equal to v square by en.
So can you go to previous slide?
Yeah, just a minute. 91.6 square divided by 5.36. Calculate and tell me the answer. Yeah, I don't have final answer for this. But the number should be a little bigger, I expect.
The tangential component will not affect the vertical acceleration. Like at sine alpha is equals to plus minus an cos alpha is equal to g.
Okay. Yeah, 80 we have there, right? Mm, See, mm, uh, okay. 80. No, I think here it should not come, because um, we are working on acceleration, not because of the change in direction, only because of the change in direction. Okay, so I think in this case only an should come. Okay, if say because we are not calculating the total acceleration a. Okay, uh, here I am not assuming like total acceleration a is equal to let's say some total acceleration, and then in that case, yeah, we may have to take both at and en. But this is like um, working against the gravity. So in this situation, we should take only an.
That's both component will affect like gravity. Uh, Horizontal component is zero, like acceleration an plus at sine alpha, at cos alpha, and an sine alpha will be zero. Addition of them. You can put into that and find the an from that equations.
Uh, See, let me explain you. It will not be zero horizontal so okay, let me explain you. Uh, so what is the situation here? Yeah, we got 80 here. which is making an angle alpha, right? So 80 cos of alpha, and I think somewhere like this we have an, yeah, making an alpha, and yeah, the component of it is again an, um, yeah, maybe yeah, sin alpha you can say. Okay. Yeah. Okay. Yeah. And yeah, two component vertically. Yes, it is 80 sine of alpha, and here, yes, 80. Sorry, an cos of alpha. Yeah, I think this is right. You should. What you can do is you will take a make one relationship here. That is 80 cos of alpha is equal to, um, what you can say, minus an sine of alpha. Okay, you will get one relationship here, right? And another equation what you will get here is 80 sine of alpha minus en cos of alpha is equal to 9.81. Okay, so from these two calculate the value of 80 and an and put it here, not this one. Okay, so get the value of an here, and then equate it to v square by r. Yes, just rub this part. Yeah, and then tell me the value of r here. So after solving these two equations, what is the value of 80 and an? Anyone? Uh, can you tell me, Ian, what is 80 and an? Alpha value you already have, right? What is alpha? Alpha is equal to 56.9. So just put it here and tell me the value of 80 and an. Okay, so maybe, hmm, help you out. 80 will be equal to, okay, Pranjul, what is this? This that is value of 80, 5.3.
AN's value, sir. AN value 5.3.
An is 5.3. Okay, and what is 80? Just to make sure this satisfying the equation.
Sir, 8.13, sir.
8.13. Okay. Others are also getting the same answer. Just check it, since I have not calculated it. You can just confirm. Others, you can put into these equations and check whether um, these two are satisfying these two equations or not. Okay, then in the meantime, yeah, if it is correct, then 5.3 should be equal to v square by r, and r is equal to an by v square. So then you can just calculate it. An is 5.3. 5.3 divided by v is 91.6 square. How much you are getting? R Who is this, Pranjul or Abhishek? Hello.
Yes,
Yeah. How much? You can post the answers
very
quickly.
nice. 0.0066, very nice.
Okay, Shrujana got 17.13. Abhishek got 17.09. So everyone is getting different answers here. Can you solve these two questions and tell me the value of AT and AN? Is it correct or not? Um, Abhishek, Deepa, Shri, and Sujana, are you also getting the same answers or different? Okay. Okay, then maybe you can solve it. And but yeah, you can solve it. I don't have the values here. You can solve it, but ultimately, this is the overall idea. Okay. So I'll repeat the question what they have asked here. So this particle was thrown here. After 1 second, what we did is we calculated the velocity. Okay, velocity will be the direction of the velocity is now different because initially it is making a 60-degree angle. Angle will slightly reduce. Okay, and velocity will also reduce because we are working against gravity. So velocity now became 91.6 from 100 meters per second. Okay, also the angle is reduced from 60 degree to the 56.9 degree after just 1 second. So at this location, okay, as let's say we have thrown the particle upward, uh, the value of velocity is perpendicular to the, or sorry, tangent to the curve. Along that we have tangential component of the acceleration, and yeah, and then we have normal component of the acceleration acting towards the center. Okay, and then we have, yes, Vy and Vx. Yeah, just tell me, just one correction here. Can you tell me whether this AT value is correct or not, or AT direction correct or not? What is AT? AT is generated because of change in magnitude of the velocity. So uh, here, what is the let's say direction? Whether I have the direction which I have shown is correct or it is wrong. Hello, can you tell me the direction which I have drawn here is correct or wrong? Why it is correct, Pranjul?
Sir,
Abhishek?
it is a tangential acceleration, so it will be on the
Yes.
tangent to the curve path.
Yeah,
So,
but it is upward or downward? It should be downward, right? What is acceleration? Change in the velocity with respect to time, right? Whether our velocity is increasing or decreasing with respect to time.
decreasing, sir.
Yeah, yeah. So
That's
just
why
make
some
that
negatives
correction.
are in equations, some negatives are, that's why last
Yeah.
time.
So
8.2.
you just have to what you have to do is let me just tell you at this point itself. Um, by red pen, I'll just change the direction. Okay. Um, okay. This like this. Again, stuff will remain same. Nothing will change. In this slide, at least, everything will remain as it is. And in the next side, AT is equal to plus En sine of AT will be in this direction. So AT will be equal to AT this alpha, this alpha, cos of alpha. Okay, so at cos of alpha is equal to an sine of alpha. So basically you will get at is equal to an times cot of alpha. What is alpha value? 56.9. Okay, put this value of at into the below equation. What is below equation now? En cos of alpha plus at sine of alpha is equal to 9.81. Okay, so now this is more correct. So just put it here, at value En cot of 56.9 plus En cos of 56.9 is equal to 9.81. From this, tell me the value of an. From this, tell me the value of an quickly. What is the answer?
Sir, AT will be AN sine and AN tan alpha, tan 56.9.
Yeah, 10, right?
Yes, sir.
It is equal to
Answer
n
here
10.
AN 1056.9 into, uh, sir, AN is correct sine alpha only. AT sine alpha, AT tan alpha, and sine alpha, sine 56.9 in multiplication. Because AT value is AN tan alpha, so we have AN sine alpha tan 56.9.
Yes, sir. Yeah, correct. I think it's correct now, right? I have corrected it. Yes, because sine of theta divided by cos of theta is tan of theta, so it should be equal to an tan of 56.9. So just put it here, 80, um, yeah, tan of
So
alpha
sine
into
will
sine
also
of
come here. Sine,
yeah,
sine
sine
will
of
also.
alpha. Yeah. So just this is just the value of 80. So from this, tell me the value of en. Tell me the value of en. I don't have calculator with me. Tell me the value of en.
So same comes from 5.3 only.
5.3 you are getting.
Yes.
Okay. So you'll get en is equal to 5.3, and then yeah, from that just calculated the value of r. 5.3 divided by 91.6. Yeah,
Sir, hello.
Yes.
Excuse me, sir. It should be here an 1056.9 into sin
Sin al
56.9. So that means 10
Yeah,
alpha
that
into sin alpha. Sir.
yeah, I have written it right.
Okay, 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 sir.
Uh, How much final answer? Okay, just do this division and write the answer then. If you are not telling me. Okay, something maybe 0 point something, 0.06 maybe something. Yeah, okay. Yeah, okay. Anyone have any doubt?
Hello.
Yes.
So here it should be. Can you go to the next slide, sir?
Yeah.
So here it should be v square upon r is equal to a n, no, sir.
Yes.
No, sir. Here, below this one, sir. Here written r is equal to.
Yeah. Okay. Square it. So tell
No,
me the
sir.
answer.
No, sir. It's here. It's reciprocal, sir. In v square should be
Okay. 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 Yeah. So what we are interested in R, right? So it's v square by an. And yes, thank you. V square here is how much? 91.6 whole square divided by n is 5.3. Is it correct now? Yeah, I think it should be correct now. Let me just calculate in my mobile. 91.6 into 90. Yeah, 15 something. Okay. Yes, right. 1583 something. Yeah, now it makes more sense for the answer because if we are throwing some particle which is making a 60-degree angle with horizontal with some 100-meter uh, per second velocity, then at least it will have some significant number of, let's say, radius of curvature, not the very small number, okay, because that particle will be uh, at certain height, okay. So let me repeat this question as we have did some corrections here, okay. So particle is thrown up in the air with a velocity of 100 meters per second, making an angle 60-degree with the horizontal. Determine the radius of curvature at the time 1 second. As we are working against gravity, initially velocity is 100 meters per second, later it became 91.6 after 1 second, right? We just calculated. So during this 1 second, changing the velocity is negative. It means it's a deceleration. So that is the reason AT direction should be downward. Okay. N is always towards the center. Okay. And at this location, we have also calculated the alpha value, that is Vy by Vx, and that is 56.9. In order to calculate the radius of curvature, we should calculate the En, because En is equal to V square by R and R is equal to V square by En. Okay, so we got the V square, that is 91.6 square, but En is unknown. So let's calculate En now. We know that downward component of the acceleration is 9.81. So total vertical component is the vertical component of the AT, that is 80 sine of alpha, okay, and an cos of alpha. The sum of these two should be equal to 9.81. Okay, and one more relationship which we can use is this, uh, which gives us the value of let's say an is equal to 5.3. Okay, and r is equal to v square by an. So we just have calculated 91.6 whole square divided by an, which is 5.3, gives us 15.83. Okay, so just make sure we corrected here the direction of at. It is downward, and that is why we have removed this negative sign. Okay, go through this question once again whenever you have some free time,
Hello.
as we have did some correction. Yes,
Hello. Hello.
yes.
Excuse me, sir.
Yeah,
Sir, I was doing with some different doing using mathematics like sir. I
yeah.
converted the equation in a xy form, sir, and then I
Okay.
differentiate. I use then I differentiate dy by I found dy by dx and d2y by dx square. And then I use the formula r is equal to 1 plus dy by dx whole square to the power 3 by 2 upon by d2 by y upon dx square, sir. Can you use this one, sir? There is a formula for radius of curvature, no, sir.
Yeah. Okay. Ready? You tried to use the radius of curvature formula.
Yes, sir.
Okay. I don't remember the exact formula, but what is that formula? Can you tell me?
Yes, sir.
Mm.
That is, sir, 1 plus dy by dx whole square.
Uh-huh. That's all.
Divided by, yes, divided by d d2 y upon dx square. Yes, sir.
Okay. This one. Just let me check. Is it correct?
And sir, there should be 3 by 2, no, sir. 3 to the power 2, sir. Upper,
Where
upper side, sir. Upper side, sir.
d
It's
1
not a
plus
root,
dy
sir.
by
No,
dx.
no, sir. It should be 2, sir. The whole power should be 3 by 2.
Okay. Yeah.
Yes, sir.
Okay. So you have created a equation for the curve.
Yes, yes,
Okay,
sir.
and then you calculated the
Yes,
radius of curvature at that particular instant. Yeah. So
yes, sir.
how you calculated the equation of curve here? Just by like
Uh,
those 2 points.
y is equal y is
Yes.
equal to u to u y is equal to
Uh-huh.
uy t y equal to u y component of velocity
Yes. Okay.
vy,
Uh-huh.
sir.
Okay. Okay.
Uh, no, sir, y is equal to, so y is equal to
Yes. Huh?
vy
Uh-huh.
minus में half gt square vy minus में half gt square
Okay. Hmm.
vy t sir,
Okay. You.
and
Okay. Vyt minus half of gt square.
minus half gt.
Uh-huh.
And then there's another equation, sir. X is equal to vx into me t, sir. I derive the t.
Okay. So this is your Vy and this is your Vx, and
No, sir. No, sir. It's y only, sir, not a vy, sir.
okay. Okay. Fine. And x is equal to Vx times
Vx
t.
into me t.
Okay.
I derive the t here, sir, and put into this
Okay.
one.
Okay.
Then I got a equation y in the term of x, sir.
Okay. So how the okay. So basically, mm, yeah, I understood your point. What you have done here is, so this is the how velocity is changing with respect to y direction.
Yes, sir.
So this is
Yes, sir.
v y, you can say, and this is, let's say, v naught y, mine v
No,
naught
sir.
y t.
It's a y, no, sir. X is
How will
t
you
plus half
calculate the
g square
vy
y.
v1y? Can you tell me how you calculate v1y?
No, sir.
V
It's
naught
a
y.
vy. It's not should.
Yeah. Okay. Yes. Yes. Okay. It is.
Hello.
Yes. 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 Okay. Understood. Understood. So this is your S, right? Okay. Just Y.
Yes,
Okay.
sir. Yes, sir. Y.
Vertical
This is
height.
a
Right. Right. Hmm.
yes, sir. Yes, sir.
And
You
in
know,
this method,
I
what
will,
answer you are getting?
sir. I was. It's getting such too complex. I was getting
Okay,
around of this one, sir. This one, around of this one only,
50.
sir.
Yeah, then I think this is also looks correct method. I don't like think it's wrong, because what you are doing here is how x is changing with respect to um,
Why?
time, and
Yes, sir.
how y displacement is changing with respect to time. Okay,
Yes, sir.
looks correct. Uh,
I totally
so
derive a y into the in term of x, sir. And then I found the derivative.
okay, so what dy by dx is equal to dy by dt, and then you
And
multiplied
implemented.
maybe dt by dx, right?
Yes, sir. Yes, sir.
Mhm. Yeah, or maybe divide with a dx by dt rather. Yeah,
Yes, sir. Yes, sir.
yeah. Okay. So yeah, so then you should get a
For
relationship between uh, y and x.
d.
So you
Yes,
get dy by dx equal to some equation in terms of y and x, and then
yes,
maybe by variable separable, you
yes,
can get the
yes, sir.
relationship
Yes, sir.
between y and x. Okay, good.
Yes, sir. Yes, sir.
Um, y as a function of x, right?
Yes, sir.
And then uh,
I double differentiated.
okay, and then you applied this formula.
Yes, sir.
Yeah.
At this.
Uh,
Yes, sir.
yeah, I think this should also be correct.
I was
And
getting around of 1500, 1500.
something. Yeah.
Yes, sir. Okay, sir.
Yeah,
Thank
uh, 1570 or something is the answer, right? What we got, 1583. Is it correct? Just confirm. Maybe one has, because I have not used calculator here. Let me, or this exact figures, exact numbers. If you don't use, then if your answer is around it, then I don't think it's wrong. Your method is also correct. Looks, at least from the point, it looks correct, because you generated this curve and then found out the radius of curvature r. Okay. uh, so process wise, I don't think like it is wrong, but maybe a little time consuming than what we have explained before, because here yeah, actually I was not aware of this formula. Yeah, maybe I don't remember it, but yeah, it's good that you remember, and you we can apply here, but just little bit more complex here. Um, Finding the dy by dx and then integrating it, getting y, and then again differentiating it. Yeah, but yeah, this method is also correct, and it's good that you are getting similar answer. What's your good name?
Abhishek Arya.
Yeah, okay, okay, good. Yeah, yeah. Okay, I'll give you one more question. Let me give you one different kind of question now. Yeah, position vector r bar is equal to 5ti plus 3t square j plus t cube by 3k. Okay, where r is in meter and t is in second. R is in meter and t is in second. At the instant when t is equal to 2 seconds, the radius of curvature is. Okay. Question is more or less similar to what we have studied before. Slight change is there, okay, because there I have clearly given you the value of velocity and initial velocity and angle with which we are throwing it. Here it is a little bit different. Here we have the position vector, okay, r with respect to time, and um, you have to make use of it. Okay, just give me 1 minute. I will connect the charger. In the meantime, you can solve this question. Okay, try to solve this question. We got the value of r bar here. Velocity is not given, but r bar is given, so you should be able to calculate the v bar, right? And you can also calculate the a bar, acceleration. The position vector r bar is given like this. What is r bar? Iti plus 3t square j plus t cube by 3k. Okay. V bar is the dr bar by dt, right? Differentiation of r bar with respect to t, 5ti. So it's a 5i plus 6j plus t square k. 60j, sorry, yeah. And velocity at t is equal to 2 will be equal to 5i plus 12j plus 4k. Okay. And mod of v bar is under root of 5 square plus 12 square plus 4 square, and that will be equal to 13.60 meters per second. Okay, and similarly the acceleration uh, Srujana, no, 15.85 is not the correct one. A bar is again differentiation of V bar with respect to time, that is 6j plus 2tk, and again A bar at t is equal to 2 will be equal to 6j plus 4k, and mod of A bar is equal to under root of 36 plus 16 under root of 52, and that is 7.21 meters per second. Okay. Uh, yep. So what is expected here? Radius of curvature. Radius of curvature, the only way to find it is v square by n. Last time we have calculated. If you know the value of n, we can calculate the radius of curvature. You already got the value of v. What is v? 13.60 whole square divided by n. So only thing you have to calculate is an now. How to calculate an? That is the question. You got the value of a, but you don't know the n. Okay, what is the value of a? 7.21. 7.21 is the a. So a square is equal to tangential velocity acceleration square plus normal acceleration square, right? So 7.21 whole square is equal to 80 square plus an square. So at least if you get the value of 80, then you can get the value of an. Okay. How will you calculate 80? Anyone? Can I say 80 is equal to a bar times, let's say, v cap, a bar dot v cap? Is it correct? What is v cap? Unit vector in the direction of the velocity, right? This should be the correct way to, yes, acceleration in the direction of velocity. So that is a bar dot v cap. And what is a bar? 6j plus 4k. And v cap is what? 5i plus 12j plus 4k. Divided by mod of v bar, that is 13.6. So 1 upon 13.6 into 0 plus 72 plus 16 should be 88 divided by 13.6, and how much? Something 6.4 or maybe, yeah, meters per second. Okay, take it one, take this one, 80. Okay, for 6.47. Okay, yeah, 4.67. Now you got the 80 and you know how to calculate n now. 7.21 whole square is equal to 6.47 whole square plus an square. What is value of an? 3 point something. No, it should not be big, Abhishek. Okay, you are telling me the value of r. R looks incorrect. It is en is 3.18, yes, meter per second square. So if you got the a 13.60 whole square divided by 3.18 should be 58 something, right? Check it. Yeah, 56, 58, right? 58 is the correct answer in this case. Anyone have any doubt in this question? Here also we use a little bit of concept of vector calculus. We know the if you want to calculate the component of some vector in, let's say, component of acceleration in tangential direction, then it will be at, and that will be equal to the acceleration into the dot product with the v cap. Okay, and what is v cap? It is the velocity, unit velocity vector. Okay, and rest of the things are clear, I hope. And the final answer in this case is 58. Okay. So from this, I have given just one question for homework. You can try it later. If you are not able to solve, then I can help you. And maybe from next week, see what we'll do is um, we'll give some questions apart from class. Let's say, okay, maybe in between some other day, I will post some question on the group, and you come up with the answers, and then at least to make you active during the free time. Okay. See, some syllabus is common there, like which such as instantaneous center, and that should be covered in the theory of machines, because whenever you study the topic, let's say uh, that topic, mechanisms and machines, the instantaneous center is should be covered. Okay, but if not, maybe one just single question I'll take on it, so that you will get idea what I'm talking about. Okay, let's take one question. A ladder shown in the figure. So this question is not mainly from mechanics, I would say it's from the theory of machines. Slides over a smooth vertical and horizontal surface. At the instant shown in the figure. Okay, the velocity of point A on the ladder is 3 meters per second. The velocity at point B is okay. So let me show you the figure. Okay, this is the ladder. 3 meters. This is A. This is B. This is 4 meters. So ladder is 5 meter. Okay. Yeah. So this is sliding down at a velocity of 3 meters per second. Is it clear? No question? So what they are asking you to calculate is the velocity at point B. So do you agree that if the ladder, the surface is smooth, the point A will come downwards and B should go here, because there is no other way that A will go upward, right? So this uh, this problem you can consider to calculate the VB. Okay, anyone got the answer? It's not difficult question. Okay, I'll give 1 more minute to you to think on it. So if you put a ladder, the vertical and horizontal surface is smooth, it is clear that it will slide down. So he is coming down at a 3 meters per second. So what is the B point at going away? What is the velocity of point B? Yes, 2.25 is the correct answer, Abhishek. See, what is assumption here is like, yeah, if you draw the dotted line. Okay, so it is like you can assume this as one single link. Okay, and this link is rotating about this instantaneous center of rotation. Okay, so if you draw the perpendicular to the velocities, wherever it cuts, so this is the point, so you can call it as IAB, that is instantaneous center of points A and B. What is instantaneous center? The center with respect to which whole body is assumed to be rotated. Assumed to be fixed axis rotating, or assumed to be undergoing fixed axis rotation, you can say. Okay, at the given instant of time. Okay. Because after some times the B point will be at different location, A will be at different location, so there will be different instantaneous center of rotation. Okay, so at this particular instant, this is the instantaneous center, because if you draw the perpendicular to the velocity, that is where it meets IAB, and that is instantaneous center of rotation. Okay, I see, you can say. So let's say it is rotating at omega. So you can assume this entire as one link rotating at omega angular velocity. So what is velocity of the point B? You know, velocity of the point B is given by r omega, right? So that is distance from, let's call it as this point as OB. Okay, the distance OB into omega. Okay, omega, and that will be the velocity of um, point B. What is velocity of point A? That is 3 meter per second, and that is equal to OA into omega. So OA value is 4. So the omega value which you will get is 3 by 4. Okay. So if you put omega here, OB is what? OB is 3. 3 into 3 by 4. That is equal to 9 by 4. And what is that value? 2.25. Okay. So that is why 2.25 is the correct answer in this case. Okay. This is just for your information. Yeah. Yeah. Yeah, I would say this is not part of mechanics, because here we are talking about the links, the angular velocity of the eye centers and all, and it comes in the theory of machines. So um, but this is just for your information, like um, uh, uh, how to deal with this kind of questions. Sanjeev, what relations you are talking about? Okay. Yes, you can do that, Sanjeev. Yes. Yeah, that should also give you the same answer. Because this is, let's say, you can assume it as a rigid rod, and along the direction of the rigid rod, the velocity will be same. Yes, it should also give you the same answer. Are you using the same method, Sanjeev? You got the same answer? Yes, yes, yeah, that is what Sanjeev is also explaining. So what you can do is, the another way to solve this is, um, take the component of A, okay, along this, and also the component of B along this, okay, and then you will get the same answer, okay. So that also is the correct method. What only thing you have to do is, you have to calculate the angles. So this is 3 4. You may have to calculate this angle, tan inverse of 3 by 4. You'll get some angle here. You will also get some angle here, that will be 90 minus that, okay. And then take a component of the, let's say, velocities along this line, and you can, let's say, equate it rather, okay. Yeah, and whatever will be the answer, that you will get the VB basically from it, okay. So yeah, that is also correct method. Okay, Abhishek has got the angles here. This is 37 and this is 53, okay. um, yeah, and this is already 90, so you take a component of that and equate it. In that way also you should get the 2.25. So that method is also correct. Yes, Sanjeev, you are right, you can use that. Okay. Yeah, but here I just wanted to introduce, like, this kind of problems are still there, like, but mainly I would say, it is not on the scope of the mechanics, okay. So you don't have to worry. Yeah, and about the eye centers, uh, it is, like, I would say, mainly for mechanical students, and you will learn it in detail when theory of machines will start, okay, because this is one of the very most important method to calculate the velocity of link whenever it comes to a mechanism, okay. Fine. So as of now, that's all I have for the kinematics part. Just to recall what we have studied in the kinematics is, we studied a variety of problems, and theoretical part little bit, because there is not much in kinematics. We only have um, velocity, acceleration, and displacement, nothing else, and we are learning this from class 8, okay. But here what we understood in detail is, like, if it is a variable acceleration problem, we have to work with differentiation and integration in order to solve it. Also, um, whenever, let's say, we have constant acceleration problem, we have to use equations of the motion, and uh, then the projectile motion related problems, right? How to find the velocity after a certain time, how to find the range, h max, time when we reach the maximum height, and the t range. We have studied the derivations of all of this, including the equations of the motion, and studied a lot of problems, okay. So that's all we have from the kinematics part, and I'll now start the kinetics part. Okay, we have some comments here from Abhishek and Sanju. Question banks. Okay. Um, yes, I will share it. Okay. But see, what I can do is I can in class, if I just give you question, it will take like half of the time just giving you the sample questions. So one or two questions I can give in the class. Rest we are solving anyway. And apart from class now, what I'll give in directly, I'll post it in the group now. Okay, Abhishek and Sanjay, you can uh, maybe from next week, Monday or Tuesday, I will collect some questions and I'll post it in the group, and then you take it. Okay. In class, I'll not give much questions for homework. I'll just give two questions more or less in the each class, but more questions I'll give um, in WhatsApp group. Okay. Yes, yes, yeah. Practice is very important, and we will do it through WhatsApp group. Okay. Also, after the completion of syllabus, I'll take again some questions starting from the beginning. Okay, just to make you familiar with little more questions, and just as a revision of what we have studied. So we'll have again a doubt clearing session and proper problem solving session at the end. But for regular practice, I will send you questions through our WhatsApp group. Yeah. Okay. Write down heading kinetics. Yeah. What is kinetics? As you know, uh, kinetics is like um, branch of the dynamics that deals with the study of the motion of the body, considering the forces applied on it. Okay, for forces causing the motion. Now, as I said previously, when I was giving you the overall insight about this topic, that in this topic we will our main focus is in studying the different theorems, okay, or principles. So let's say this body is there, which is moving on a horizontal surface because of certain force P applied on it. Okay. The weight of the body is W, which is acting in downward direction. The normal reaction will be still there, that is N. But let some friction force is there, or let's say it's a frictionless surface, smooth surface, so no frictional force. Mm, So can I apply the equations of the equilibrium in this case? Can I apply the equations of the equilibrium? Can I say, uh, let's say, summation of all y, summation of all forces in y direction, summation of all forces in x direction is 0? Can I do it? Hello? No, right? Because we cannot do it. Um, because body is not in equilibrium. Then how to solve this kind of problem? Becomes a little bit difficult right now, uh, because the body is not in equilibrium. Because this is our direction of motion. Okay, and our body is in acceleration in this direction. Okay, so you know force is equal to mass times acceleration. force is equal to mass times acceleration. So if you apply, let's say, one imaginary force ma in this direction, okay, let's call it as a inertia force, or let's say an imaginary force, which is an imaginary force, okay, such that the summation of all forces acting on the body in the horizontal direction is equal to the mass times acceleration. Okay, so I can say summation of all fx minus ma equal to 0, and let's assume this as a dynamic equilibrium equation. Let's call it as a dynamic equilibrium equation. Okay, so that is what we are doing here. The way we are applying the equation of equilibrium in the dynamics is by assuming the imaginary force in the opposite direction of the motion, and that is equal to the sum of all the forces in the um, moving direction, in the direction of motion. Okay, and that is what is described by a D'Alembert's principle. So write down heading D'Alembert's principle. Okay, drawing free body diagram, drawing free body diagram and representing all the forces, and representing all the forces, including the inertial force. Okay, that is mass time acceleration. Helps in forming an equilibrium condition. Helps in forming an equilibrium condition, and is represented as D'Alembert's principle. Okay, so yeah, yes, Abhishek, summation of y we can anyway do because the body is not moving in the y direction. Um, so weight is equal to the normal reaction, you can say. Okay, suppose friction is acting, then in the previous example, P is acting in rightward direction, minus mu times N is the force which is in the leftward direction, that is frictional force, you can say. So P minus F minus Ma is equal to 0. So P minus F is equal to mass times acceleration. So what is mass? That is weight of the body into acceleration divided by g. Okay, so in this way also you can derive these equations. Okay, so let me just draw here the um, F frictional force, Fr. Okay, is it clear till this? So you understood what we are doing in D'Alembert's principle. Can you tell me, like, mm, in which situation you will use the D'Alembert principle, or uh, in what kind of problems you can use basically? Non-inertial. So yeah, I would say, like, Then in the dynamic problems where you are, let's say, maybe acceleration is given or is supposed to be calculated, under such situation you can go for under such situation you can go for D'Alembert's principle. Okay. Sorry. Mm. Because we have an acceleration term here in the formula of the inertia. Okay. In the inertial force, this is mass time acceleration. So mass of the body is given and the acceleration is given, then you can use it, or acceleration is supposed to be calculated, then also you can use it. Okay. So let me give you some questions from this D'Alembert's principle. A block of weight 2224 Newton is resting on a rough horizontal surface. Resting on rough horizontal surface, having coefficient of kinetic friction mu k. Okay, mu k is now different. It's not the mu which we were studying before. Mu k is coefficient of kinetic friction because body is moving. Point 2. The value of P as shown in figure, that will give the body acceleration of 0.2 times g. G means 9.81. Okay, meter per second square. Okay, a block of weight 2224 Newton is resting on a rough horizontal surface having coefficient of kinetic friction. I already explained you when we studied friction. There are two types of friction, static and dynamic. You can also call it as kinetic. And the theoretical background and all I have already given to you. So I'll not go into that details. So just this is the force P, which is acting at an angle of 3, and this is 4. Okay. Yep. All this. Yeah, 889 may be correct if it is a horizontal force, Abhishek. Yeah, it should be. Look, let me just calculate it. Yeah, 889 is for the horizontal force P. Here, little bit different. Your answer may be more than that because we want now 889 Newton horizontal component. If we want that horizontal component to be 889, then the actual force at this angle should be a bit more than that, right? Yes, anyone have solved it? No, Pranjul. 889 is correct answer for this kind of figure. Okay, for this 889 is correct. For this, the answer is 966.95 Newton. Okay, let me explain you. Uh, so this is P. This will be 0.8 times P, and this will be 0.6 times P. Okay, the weight will be acting downward. Normal reaction will be acting upward. Frictional force will be here, mu times n. Also, the mass time acceleration, that is D'Alembert's force, or you can also call it as the inertial force, will be acting in leftward direction. Okay, so if you apply summation of all vertical forces equal to 0, because now because of this inertial force, the body is in dynamic equilibrium, and summation of all vertical forces equal to 0. So n plus 0.6 times p is equal to 2224, right? So this implies the value of n is 2224 minus 0.6 times p. Call it as equation number 1. Summation of all forces in the horizontal direction equal to 0. If you use that, px, that is 0.8 times p minus mu times n. So 0.2 times n is what we just have calculated, 2224 minus 6p minus 0.6p mu n equal to sorry, minus ma, mass times acceleration. So 2224 into 0.2 into g, and this is weight, so you should again divide by g, and that is equal to 0. So g will get cancelled. So 0.8 p minus 0.2 times 2224 minus uh, 0.6 p uh, minus 2224 into 0.2. If you solve it further, I think you should get p as 966.95. Okay, just check it. Okay, and in this in the second example, if in this kind of question, if they ask, it's very simple. Here p will be equal to uh, what is p will be equal to the frictional force, that is mu times n. So that will be zero point 0.2 times n will be in 2 to 4 plus the mass times acceleration, that is 2 to 2 4 into zero point 0.2 into g by g. G will get cancelled. So 2 to 2 4 into zero point 0.2 into 2. That's all. Okay, and that is 889.6. Okay, so if okay, clear, 966.95 is the correct answer. Some of you already solved it. Okay, let me give you one more question. Yeah, because as we have very less time, let's take one more question and we'll complete it. Two equal weights W and a single weight Q attached two ends of a attached to two ends of a flexible but in extensible cord. Full stop. Overhanging pulley. Overhanging the pulley shown in figure. Okay. If the system moves with the acceleration A as indicated by arrow, neglecting air resistance, inertia of the pulley and friction, the magnitude of weight Q will be. And options are option A, Q is equal to 2 WA divided by G minus A. Option B, WA divided by 2 times G minus A. Option C, WA divided by G minus A. And option D, WA divided by G minus 2A. Okay, it's the inextensible, not extensible. Okay, you can say. Okay, it will not extend. We are studying mechanics, so it will not extend. Okay. Because we are not considering any deformation and all in our study. Figure looks something like this. This is the weight. This is another weight. And this is the Q. And this is the acceleration E. Okay. I'll repeat the question. Two equal weights W and a single weight Q are attached to an flexible but inextensible cord overhanging the pulley shown in the figure. If the system moves with an acceleration as indicated by arrow, neglecting the air resistance, inertia, and the friction of the pulley, the magnitude of weight Q will be. What is the value of Q? Okay, this is previous year question, one of the previous year question. Okay, let me help you out. Let's try with the free body diagram of first body. The downward weight is W and T is the tension in the string. As you know that this weight is moving in this direction, the motion is in this direction. This is the direction of motion. So in order to apply the equation of equilibrium, or in order to make a dynamic equilibrium case, then inertia force of mass time acceleration has to be applied in downward direction. Mass time acceleration means W divided by G into A. Okay, so I can say here T is equal to W plus WA by G, and you can in short write it as W times 1 plus A by G. Okay, so this is the um, let's say tension in the string. Yes, Abhishek, A option A is correct in this case. Then apply the freeboard, the same strategy to the freeboard diagram of second figure. So let's consider this as a second figure. Overall, we have, let's say, W plus Q acting downward. So tension will be there, and this body is moving in this direction. So this is the direction of motion. So this will be the mass times acceleration, that is inertia force. Okay, and whose value is mass time acceleration, that is W times Q divided by G times A. Okay, so you can say here tension in the string plus W plus Q times A by G is equal to W plus Q. Tension in the string we have just calculated in the previous slide, that is W times 1 plus A by G. If you put here in the second equation, what ultimately you will get here is W times 1 plus A by G is equal to W plus and just multiply this A by G inside, what you will get? W A by G, and from there take W here, and Q stuff will keep it that side, so Q minus QA by G. Okay, so I have taken all W terms on the left side and Q terms on the right hand side. If you take Q common here, 1 plus 1 minus A by G you will get. Okay, uh, so from here, so this is W plus WA by G plus WA by G minus W. So here plus W minus W will get cancelled. 2 WA by G is equal to Q times G minus A by G. So this GG will get cancelled. Q equal to 2 WA divided by G minus A. Okay, hence option A is correct in this case. Okay, are you following? So D'Alembert's principle, very simple. Body is not in equilibrium because it's in motion, and in order to apply the equations of the equilibrium, we have to generate or artificially create a situation of it by considering an imaginary force, which you can call it as inertia force, applied in the direction to the opposite of the motion, and the magnitude will be equal to sum of all the forces in the direction of motion. Okay, and that will help you to use the equations of the equilibrium and solve the problem. Is it clear till this? Any doubt? Is it clear the D'Alembert's principle? Any doubt till this? Okay. So if no doubts, then in the upcoming sessions we'll solve some more problems. I'll give this week. I'll give some questions to you on the WhatsApp. You solve them, okay? and we also have to study work energy principle. Apart from this, then we also have to study impulse momentum principle in this. Okay, and problems on it. And yeah, so, and once that is done, then we'll study the remaining topic of virtual work at the end. Okay, so um, in the next class, our focus is mainly on studying the theorems, okay, and solving the problems. So that this concept of, let's say, impulse momentum principle, work energy principle, D'Alembert principle is clear. And once it is clear, then we'll study the remaining topic of virtual work and the problems on it. Okay, and that's how we'll proceed in this week. Okay, any doubt till this? If no doubt, then we can close the session. Thank you all for joining this class, and let's meet again next week. Thank you all. Bye. I'll upload all these slides to the dry location, okay, in the PDF format. So thank you all. Good night. Bye. No, Sanjeev, WhatsApp group. Um, we are advised to share it through the dry location only. So I think it's better to use it. I will upload in what dry location. If you don't have the dry location, I can share it with you through WhatsApp. Okay. Yeah, I'll share the dry location to you. Yeah, that's all then. Thank you. Bye.